Our objective is to make a pop-up boat by using thermodynamics to make it move.
So the material we use, first for the boat, we use some material that it's used for fragile stuff, because we saw its density was really low, so the buoyant force was really high. We also use tin cans for the drums, made of aluminum, and some straw, and that's pretty much all the material we use.
So the boat was intended for a cardboard of milk, but we adapted to a shape of polystyrene that we wanted. The shape of polystyrene would be the base of our boat. Then after we had the base of our boat, we will do the drums that are made of tin cans. This will be folded in a form of a rectangle and will be pasted with plastiloca so they do not have a leak or they do not have any kind of problem. The drums will have a straws connected to them so it can release the water. So that will be the part that will move the boat. Also we use candle bases that will have solid alcohol. That will be our candle, because we learned that it will burn more, will give us more heat so it can move the boat faster.
So we're going to explain what is the heat in physics. Heat in physics is a transfer of energy from one body to another. This is due to the difference of temperature, and also it is done by work and through transfer.
Okay, so to calculate the heat that we input it into our boat, we first got the heat combustion of alcohol, or of ethanol. The heat combustion is the amount of energy in the form of heat that alcohol or whatever material reduces when you burn it or it goes under combustion. So that value was 22 to the times 10 to the 6, and then we multiplied that by the amount of fuel that we got, and that was burned, and that was only 1 gram, so 0.001 kilograms. So we did the multiplication.
And also we got efficiency, that is the useful work over the total heat, that got us 5.75 times 10 to the minus 10.
So we use work as the formula 1/2 of mass times final velocity to the square. We use a mass of 110 grams, which was the mass of our boat with the liquids inside of the drums. We had to use final velocity as distance over time to the square. So our distance was 1 meter, with our time was 1 minute and 5 seconds, which traveled that. So we got that it was 1/65 to the square times the 110 plus 2 kilograms times 1/2. So we got a work that was 1.30 times 10 to the power of minus 5, which was our work in joules.
Our objective was fulfilled. It is not the best boat, but it delivered what we needed. The efficiency is so low, but we use thermodynamics to make movement, so it works.
The conclusion that it is very difficult to transform heat into work. We tried it with our boat, but the efficiency was really low, and we would have to have really advanced equipment to get to a decent efficiency. We tried lots of things.
We changed the material inside the drums so it has different boiling points.
We changed the combustion to have a different energy to produce.
We use different materials for the boat and for the drums.
We changed the material of the boat for a better buoyant force.
And still the efficiency was relatively the same, but overall it was pretty cool. GG.